National Electrical Code Section 406.3 covers the polarity of connections for receptacles. For receptacles rated 125 volts or less, the grounded neutral terminal must be connected to the narrow, silver-colored blade of the plug. The grounding terminal must be connected to the round, green-colored pin of the plug. Section 404.9 addresses side-wired receptacles. Side-wired receptacles must be installed with a grounding terminal located in the uppermost position. The NEC requires receptacles to be installed with the correct polarity to ensure safety. When a device is plugged into a properly wired outlet, the grounded terminal provides a low resistance path to ground for any current leakage. This helps prevent electric shock. Installing the receptacle with the grounding terminal at the top ensures that gravity will help keep the grounding wire securely in place. This is particularly important for receptacles that are mounted sideways, as it reduces the risk of the grounding wire becoming loose or disconnected over time. The correct polarity and grounding are essential safety measures in electrical installations. Incorrect wiring can lead to dangerous situations such as electric shock or fire. By adhering to the NEC guidelines, electrical professionals can ensure that installations are safe and reliable. The grounding system is a critical component of electrical safety. It provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and to energize the circuit. This prevents dangerous voltages from appearing on the metal enclosures of electrical equipment, which could result in electric shock. Proper grounding also helps to reduce electrical noise and interference, which can affect the performance of sensitive electronic equipment. The NEC provides detailed requirements for grounding systems, including the size and type of grounding conductors, the methods of connecting to ground, and the requirements for grounding electrodes. It is essential to follow these requirements carefully to ensure that the grounding system is effective in protecting people and property. Polarity refers to the correct orientation of the hot, neutral, and ground wires in an electrical circuit. The hot wire carries the electrical current from the source to the load, the neutral wire provides a return path for the current, and the ground wire provides a path for fault current to flow back to the source. The NEC requires that all electrical receptacles and equipment be wired with the correct polarity. This helps to prevent electric shock and ensures that electrical equipment operates properly. Incorrect polarity can cause electrical equipment to malfunction or become damaged. It can also create a shock hazard if someone touches a metal enclosure that is energized due to reverse polarity. The NEC specifies the colors that must be used to identify the hot, neutral, and ground wires. The hot wire is typically black, the neutral wire is white, and the ground wire is green or bare copper. It is important to follow these color codes when wiring electrical circuits to ensure that the polarity is correct. Receptacles are available in a variety of types and configurations. The most common type of receptacle is the duplex receptacle, which has two outlets. Receptacles are also available with ground fault circuit interrupter, or GFCI, protection. GFCI receptacles are designed to protect people from electric shock by detecting ground faults and interrupting the circuit. GFCI receptacles are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. When installing receptacles, it is important to follow the manufacturer's instructions and the requirements of the NEC. Receptacles must be properly grounded and wired with the correct polarity. They must also be installed in a safe location where they are not exposed to moisture or physical damage. Electrical safety is a critical concern for everyone. By following the NEC guidelines and taking appropriate safety precautions, people can protect themselves and others from electrical hazards. Electrical work should only be performed by qualified and licensed electricians. Unqualified individuals should not attempt to perform electrical work, as this can be dangerous and could result in serious injury or death. Regular inspections of electrical systems can help to identify potential hazards and prevent accidents. Homeowners should have their electrical systems inspected by a qualified electrician every few years. Businesses and other organizations should have their electrical systems inspected more frequently depending on the nature of their operations. The NEC is updated every 3 years to reflect changes in technology and industry practices. It is important for electrical professionals to stay up to date on the latest changes to the NEC to ensure that they are following the most current safety standards. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By understanding the requirements of the NEC and following them carefully, electrical professionals can help to protect people and property from electrical hazards. When working with electricity, it is always important to exercise caution and follow safety precautions. Never work on electrical equipment while it is energized. Always disconnect the power before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity is a powerful force, and it should be treated with respect. By following safety precautions and adhering to the NEC guidelines, you can protect yourself and others from electrical hazards. The NEC provides specific guidelines for different types of electrical installations, including residential, commercial, and industrial. These guidelines cover a wide range of topics such as wiring methods, overcurrent protection, grounding, and bonding. The NEC also includes requirements for specific types of equipment such as transformers, motors, and generators. The NEC is not a substitute for good judgment and common sense. Electrical professionals should always use their best judgment when performing electrical work and should not hesitate to ask for help if they are unsure about something. The NEC is a valuable resource for electrical professionals, but it is not the only resource that should be consulted. Electrical professionals should also consult with manufacturers' instructions, industry standards, and other relevant resources. The NEC is a living document that is constantly evolving to reflect changes in technology and industry practices. Electrical professionals should stay up to date on the latest changes to the NEC to ensure that they are following the most current safety standards. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By understanding the requirements of the NEC and following them carefully, electrical professionals can help to protect people and property from electrical hazards. Grounding, as mentioned earlier, is a critical safety measure. It provides a low impedance path for fault currents to return to the source, tripping the overcurrent protective device, like a circuit breaker, quickly. Without proper grounding, a fault current could energize metal parts of equipment, creating a shock hazard. The NEC specifies the size and type of grounding conductors based on the size of the circuit conductors. The grounding electrode system, which connects the electrical system to the earth, typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The NEC also addresses bonding, which involves connecting metal parts of the electrical system together to create a low impedance path for fault currents. Bonding helps to ensure that all metal parts are at the same potential, reducing the risk of electric shock. Overcurrent protection is another essential safety measure. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. The NEC specifies the maximum size of overcurrent protective devices based on the ampacity of the circuit conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The NEC provides tables that list the ampacities of different types of conductors based on their size, insulation type, and installation conditions. Wiring methods are also addressed in the NEC. The NEC specifies the types of wiring methods that are permitted for different applications. Some common wiring methods include non-metallic sheathed cable, also known as Romex, electrical metallic tubing, or IMT, and rigid metal conduit. Each wiring method has its own advantages and disadvantages, and the NEC specifies the conditions under which each method can be used. The NEC also includes requirements for the installation of electrical equipment, such as receptacles, switches, and lighting fixtures. These requirements are designed to ensure that electrical equipment is installed safely and correctly. The NEC addresses the location of receptacles, requiring that they be installed in convenient locations and that they be protected from physical damage. The NEC also includes requirements for the spacing of receptacles, requiring that they be spaced so that no point along the wall line is more than a certain distance from a receptacle. Switches must be installed in accessible locations and must be clearly labeled to indicate their function. Lighting fixtures must be installed in a safe location and must be properly grounded. The NEC also includes requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC specifies the types of electrical equipment that are permitted to be installed in hazardous locations and the requirements for installing this equipment safely. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By understanding the requirements of the NEC and following them carefully, electrical professionals can help to protect people and property from electrical hazards. Continuing education is important for electrical professionals. The electrical industry is constantly changing, and new technologies and techniques are being developed all the time. Electrical professionals need to stay up to date on these changes to ensure that they are providing the best possible service to their customers. There are many ways for electrical professionals to continue their education. They can attend seminars and workshops, read industry publications, and take online courses. They can also become certified in specific areas of electrical work. Certification can demonstrate that an electrical professional has the knowledge and skills necessary to perform certain types of work safely and effectively. The NEC requires that all electrical work be performed by qualified individuals. In most jurisdictions, this means that electrical work must be performed by licensed electricians. Licensing requirements vary from jurisdiction to jurisdiction, but typically include a combination of education, experience, and examination. Hiring a licensed electrician is important because it ensures that the work will be performed safely and correctly. Licensed electricians have the training and experience necessary to identify potential hazards and to install electrical equipment in accordance with the NEC. They are also insured, which protects homeowners from liability in case of an accident. When hiring an electrician, it is important to check their credentials and to ask for references. You should also get a written estimate before the work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. Electrical safety is a shared responsibility. Electrical professionals, homeowners, and businesses all have a role to play in ensuring that electrical systems are safe. By following the NEC guidelines, taking appropriate safety precautions, and hiring qualified electricians, we can all help to protect people and property from electrical hazards. Remember to always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity is a powerful force, and it should be treated with respect. By following these simple safety tips, you can help to prevent electrical accidents. The National Fire Protection Association, or NFPA, publishes the NEC. The NFPA is a non-profit organization that develops and publishes codes and standards for a wide range of fire and electrical safety topics. The NFPA's mission is to reduce the worldwide burden of fire and other hazards. The NEC is one of the most widely adopted codes in the world. It is used in the United States, Canada, and many other countries. The NEC is updated every 3 years to reflect changes in technology and industry practices. The NEC is a valuable resource for electrical professionals, but it is not the only resource that should be consulted. Electrical professionals should also consult with manufacturers' instructions, industry standards, and other relevant resources. The NEC is a living document that is constantly evolving to reflect changes in technology and industry practices. Electrical professionals should stay up to date on the latest changes to the NEC to ensure that they are following the most current safety standards. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By understanding the requirements of the NEC and following them carefully, electrical professionals can help to protect people and property from electrical hazards.